Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out 16 very easy practice questions that should prepare you for the mathematics knowledge subtest of both the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the pre-screening Internet Delivered Computer Adaptive Test, that is the PiCAT. As far as your performance on this practice test goes, I want to say this. Since these practice questions are considered very easy, you want to answer more than 75% of them correctly. If you answer more than 75% of them correctly, chances are you're going to have no problem whatsoever passing either the ASVAB or PiCAT. Similarly, I want to mention that in the description of this video, there are going to be timestamps that are going to be associated with each question. Next to the timestamp is going to be the topic that the question's testing, as well as a link to one of my videos where I discuss that topic in greater detail. So if for whatever reason you feel as if you need more help with one of these questions, take a look in the description of this video, and there you'll find links to my additional resources. Finally, I want to mention this. On the actual ASVAB and PiCAT, you're not going to be permitted to use a reference sheet or a calculator. So as you work your way through this practice test, try not to use any of those resources. And of course, in order to get the most out of this video, you'll want to pause the video after I read a question, attempt to work out the question on your own, and then resume playing the video to check your solution. So with all those things finally being said, let's go ahead and get started with today's video. All right, so as you can see, number one says if x plus 2y equals 10 and y equals 2, then what does x equal? So let me copy this down so people can see it in case they're viewing this video on a mobile device. We were given the equation x plus 2y equals 10. And in addition, the problem told us that y equals 2. And we want to know what x equals. So in other words, when everything's said and done, we want to get this equation to look like this. We want it to have x equal to something by itself. Well, the first thing we have to do is take this 2 and plug it into y in our original equation. So this becomes x plus 2. Again, y is 2, so let's plug in 2 equals 10. This becomes x plus 2 times 2 is 4 equals 10. To get x by itself, we're going to subtract 4 from both sides. This will cross out, leaving you with x equals 10 minus 4, which is 6. All right, so the answer to this first one is D6. And believe it or not, questions do get this simple on the ASVAB and PiCAT. So make sure you know how to substitute values into equations and then solve them accordingly. Number 2 says, what are the factors of x squared plus 3x minus 10? All right, so we're trying to factor the expression x squared plus 3x minus 10. And since this is a quadratic equation that has a leading coefficient of 1, it should look like this in factored form. It should be x times x. And now the only thing we have to do is find two numbers that multiply to negative 10 but add to positive 3. All right, that should be easy enough. What about negative 2 and positive 5? Negative 2 times positive 5 is negative 10. Negative 2 plus 5 is positive 3. So just like that, we went ahead and factored this one. And now we got to select the correct answer choice. X minus 2, x plus 5. Of course, that's going to be A. You do have to know how to factor for the ASVAB. More often than not, you'll have to factor something that's as simple as this. All right, so number 3 says, what is the area of a parallelogram if its base is x plus 5 and its height is x plus 6? So to answer this one, you first of all have to know how to find the area of a parallelogram. And it's very simple. To find the area of a parallelogram, it's simply base times height. As a matter of fact, if you look on my free reference sheet, which you can download from my website, asvabapp.com, you'll see that this is one of the formulas on there. So let's go back through this problem and identify what we have. We're told the base of this parallelogram, or its b, is x plus 5. And similarly, we were told that it has a height of x plus 6. So let's go ahead and substitute those things into this equation to find the area of this parallelogram. We know b is x plus 5, so that's going to be x plus 5. And we know h is x plus 6. Now, unfortunately, this isn't one of our answer choices because it should be pretty obvious that we're going to have to first expand this using the distributive property and then simplify it by combining like terms. In other words, we're going to take this x and we're going to multiply it here and here. Then we're going to take this 5 and we're going to multiply it here and here. So let's go ahead and do that. X times x is going to be x squared. X times 6 is going to be 6x. X times 5 is 5x. And then 5 times 6 is 30. Of course, this isn't one of our answer choices because we, again, have to combine like terms. And we should see that 6x and 5x are like terms. 6x plus 5x is 11x. So this becomes x squared plus 11x plus 30. And take your time as you look through your answer choices. As you can see, they're all very similar. And this one's x squared plus 11x plus 30. So the correct answer to this one is C. All right, so number 4 says simplify the expression. We have 2/5 x plus x. And in case you're watching this on a mobile device, let me write it right here in big letters for you. We have 2/5 x plus x. So the first thing you should recognize is that both 2/5 x and x are like terms. Again, like terms have the same letter variables raised to the same powers. In 2/5 x, we have the letter variable x raised to the first power, and in x, we have the letter variable x raised to the first power. And because these are like terms, we can combine them with each other. That said, it might be helpful if you express this 1 in front of this x. Again, 1 times x is just x. In algebra, you typically don't express 1's in front of letter variables. That said, in this case, we're going to have to do it to make this math a little bit easier. Now, some of you would say 2/5 x plus 1x is going to be 1 and 2/5 x. And that's all there is to it. That is the correct answer. But that said, if you couldn't see that, you could always work this one out the old-fashioned way. That is to say, you would have to say, well, 1 can be written as a fraction as 1 over 1. And now we're adding two fractions that have different denominators. In order to add fractions, they have to have the same denominators. So I'm going to have to find a common denominator between 5 and 1. As it happens, that's 5. So let's go ahead and work on rewriting these fractions such that they have a common denominator of 5. Well, since 2/5 already has a denominator of 5, we're just going to copy it down as is. To write this 1 a 5, to make this 1 a 5, we have to multiply it by 5. We're also going to have to do that to its numerator. 1 times 5 is 5, 1 times 5 is 5. And now that these fractions have the same denominators, we can go ahead and add them like this. This becomes 2 plus 5 over 5x. 2 plus 5 is 7, of course, so this is 7 over 5x. And now you have to convert this improper fraction, which means the numerator is bigger than the denominator, into a mixed number. And the way you do that is via long division. So we're going to read this as 7 divided by 5. Of course, we know that 5 only goes into 7 one time. 1 times 5 is 5. 7 minus 5 is 2. And now we have enough to write our mixed number. This 1 is going to be our whole number. This 2 is going to be the numerator. And this 5 is going to be our denominator. And as you can see, that is the same answer we came up when we did the mental math. So in this case, you should be able to do the mental math. If not, you have to work with fractions the long way. And as you can see, you get the same answer. All right, so that is that one. All right, so number 5 says, what is the sum of 2x squared y minus 2x plus 9 and 5x squared y minus 4y plus 5? So in this problem, we're basically adding two polynomials. Here's one of our polynomials, and here's another one of our polynomials. And when we add polynomials, we can only combine like terms. So that's going to be the key to solving this one correctly. But that said, let's go ahead and write this out algebraically. We're adding one polynomial to the other, so it's going to look like this. 2x squared y minus 2x plus 9. Again, we're just adding this to the second polynomial, so that's going to be 5x squared y minus 4y plus 5. So when you add polynomials, what you want to do is combine like terms. Again, like terms have the same letter variables raised to the same powers. And let's start by looking at this first term in our polynomial here. We have the letter variable x raised to the second power, as well as the letter variable y raised to the first power. So in order to find its like term, we have to have the letter variables x and y. Our x variable has to be raised to the second power. Our y variable has to be raised to the first power. And if we take a look, its corresponding like term is right there. We have 5x squared, y to the first. So let's go ahead and combine those. That's simply going to become 7x squared y. Now that we've combined those, let's go ahead and cross them out. Now we just have negative 2x. Again, this is to the first power. So we're looking for the letter variable x raised to the first power. This is just 9. This is negative 4y, so that's not it, and that's just 5. So there is not a corresponding like term with negative 2x. So we'll just go ahead and copy that one down as is. And now that we've done that, we'll go ahead and cross it out. All right, so in math, you typically write the letter variables before you write whole numbers. So we're going to come back to this 9. Let's jump ahead and take a look at this negative 4y. Again, we have 9 and 5, so those aren't like terms of negative 4y, so we'll just drop that down as is. We'll go ahead and cross that out. And then we have 9 and 5, which of course are like terms. 9 plus 5 is 14. So when we added these two polynomials together, we got 7x squared y minus 2x minus 4y plus 14. Let's go ahead and look through our answer choices. It starts with 7x squared y. Clearly, this starts with 17x squared y. That's not it. X squared y, that's not it. So it's either B or D. This is 7x squared y minus 2x minus 4y plus 14. All right, so that is it. And this one wasn't correct because it had plus 4y, and we know it's minus 4y, so that one's not it either. All right, you do have to be able to add polynomials for the ASVAB and PiCAT. Of course, I have 2 videos on that, so make sure you check those out if you haven't done so already. All right, so number 6 says, if 5 to the x equals 125, then what is the value of x? So we have 5 to the x equaling 125. The way you want to think about this one is like this. What is 5 squared? This means x would be 2. 5 squared is the same thing as 5 times 5. And 5 times 5 is 25. So clearly, x is not going to be 2. What is 5 to the third? That's the same as 5 times 5 times 5. And what is 5 times 5 times 5? Well, we know 5 times 5 is 25. And what is 25 times 5? Well, let's work that off to the side so as not to make any mistakes. 25 times 5. 5 times 5 is 25, so drop down a 5, carry a 2. 2 times 5 is 10, plus 2 is 12. So we can see that 5 to the third power is 125. So this means x would be 3. And clearly, 5 to the third equals 125, so we know x is going to be 3. So the answer to this one is C. X would have to be 3. In other words, we would have to raise 5 to the third power for it to be 125. All right, so that is that one. So number 7 says if x equals 3 and y equals negative 3, then evaluate the expression x times y squared. All right, so the expression we were given, and I'm going to write this down here in case people are watching this on a small mobile device. We have x, y squared, and we were told to let x equal 3 and y equal negative 3. So let's go ahead and plug those values in accordingly. We know x is 3, and I'm going to put these in parentheses. This becomes 3, and we know y is negative 3, so this is negative 3 squared. So if it's helpful and you don't know what to do next, you can always think of your order of operations, which I remember using the acronym PEMDAS, or please excuse my dear Aunt Sally. This tells you the order in which to simplify expressions and equations. You do what's in parentheses first, exponents next, multiplication and division as they appear in the expression from left to right, that is, you treat them as equals, and then addition and subtraction as they appear in your expression from left to right, that is to say you treat them as equals. So what do we have going on in our expression here? We have 3 times, that's multiplication, negative 3 raised to the second power. Well, that's an exponent. And clearly, we're going to work on our exponent before we do our multiplication. So let's go ahead and take care of this negative 3 squared next. Negative 3 squared in parentheses is the same thing as negative 3 times negative 3. A negative times a negative is a positive. Negative 3 times negative 3 is going to be positive 9. All right, so this becomes 3 times 9. And you should know that 3 times 9 is simply positive 27. So the answer to this one is A, positive 27. Nothing too difficult there. All right, so number 8 says if 6 over 4 times 4 over 6 equals 5q, then what does q equal? So we have 6 over 4 times 4 over 6 equals 5q. And we want to know what q equals. In other words, the problem's telling us to solve this equation such that we get q equal to something by itself when everything's said and done. Before we can do that, though, we got to take care of these fractions. As you can see, we have 6 over 4 times 4 over 6. Well, when you multiply fractions, you just multiply straight across. So this becomes 6 times 4 over 4 times 6. Of course, that equals 5q. Let's go ahead and work this out, although it should be pretty obvious as to what that's going to become. We have 6 times 4, which is 24. 4 times 6, which is 24, equals 5q. 24 over 24 is simply 1 equals 5q. Again, we want to get q equal to something by itself. So let's divide both sides by 5 now. This crosses out here, leaving you with just q on this side. As we can see, q is 1/5, and in math, it's customary to write the variable for which you solved on the left. So this is q equals 1/5. I don't know why my q looked like that. My pen's starting to act up here. But q is equal to 1/5, which is answer choice D. So number 9 says solve the equation for x. We have x over 6 plus 5 equals negative 5. So we have x over 6 plus 5 equals negative 5. According to the problem, we're solving for x, so when everything's said and done, we want our answer to look like this. X equals something by itself. And as you can see, that's what our answer choices look like. So the first thing we want to do is rearrange this equation such that we get x by itself, which means the first thing we're going to do is move this 5 to the other side of the equal sign. This will cross out here, leaving you with x over 6 equals negative 5 minus 5 is going to be negative 10. All right, so here's where some people might get lost. So I'm going to actually break this apart so it's a little bit clearer. Technically, again, there's a 1 in front of this x. So we can actually write this as 1 over 6x equals negative 10. So all we have to do is clear this 1 over 6 in front of this x, and we'll have our answer. And to do that, we're simply going to multiply both sides by the reciprocal of 1 over 6, which is 6 over 1. This will cross out here and here, leaving you with just x on this side. Now, what is 6 over 1? 6 divided by 1 is just 6, so this is negative 10 times 6. And you should know that negative 10 times 6 is going to be negative 60. All right, so the answer to this one is C, x equals negative 60. All right, so number 10 says, what is 3x times 2x squared minus 5? The key to answering this one correctly is to set up an expression to mirror this word problem correctly. So the correct expression in this case is going to be 3x times 2x squared minus 5 in parentheses, which means you're going to have to take this 3x and distribute it here as well as here. So let's go ahead and perform these operations. We have 3x times 2x squared. 3x times 2x squared is going to be 6x to the third, and 3x times negative 5 is minus 15x. So clearly the correct answer to this one is A. And let me just say this. This is an example of multiplying polynomials. Multiplying polynomials is a little bit different than adding polynomials because you actually have to understand one of the laws of exponents. So if you need more help with an example like this, check out my video called Multiplying Polynomials, and you'll understand how I got this answer right here. All right, so that is that one. So number 11 says solve the literal equation for s. We have p equals 4s. And you might be saying to yourself, what is a literal equation? A literal equation is one that has a real life application. And this equation, p equals 4s, is how you find the perimeter of a square. Of course, according to number 11, we're going to be solving for s, so ultimately we want to get s equal to something by itself. As a matter of fact, that's what our answer choices look like. And in this case, it's very easy to do. To get s by itself, we're simply going to divide both sides by 4. This will cross out here, leaving you with s on this side. And as we can see, s is p over 4. And as I've said in this video already, in math, it's typical to write the letter variable for which you solved on the left. So this is s equals p over 4. And that is answer choice C. All right, so that is that one. All right, so number 12 says, what is the slope of the line y equals negative 5x plus 1? So we have this equation of a line, y equals negative 5x plus 1, and we want to identify its slope. Well, if you haven't worked with equations of lines in a long time, that may be somewhat difficult to do at first glance, but that said, you should know that the slope-intercept equation says this: y is equal to mx plus b, where b is your y-intercept and m is your slope. So clearly, m in this case, which is the slope of this line, is negative 5. All right, so the answer to this one is C, negative 5. Let me just stress this. On the very first page of my free reference sheet, this equation is there, and it helps you identify slopes of lines. So make sure you can do that. That's a very simple concept that does sometimes show up on the test. So number 13 says, if the legs of a right triangle are 5 inches and 6 inches, then how long is its hypotenuse? So if it's helpful, you can quickly sketch a right triangle, although it's really not necessary for a simple problem like this one. That said, you should know some properties of right triangles, notably that the side that's directly across from the right angle is the hypotenuse, and the other two sides are the legs. Similarly, you have to know that you can use the Pythagorean theorem to find the hypotenuse of a right triangle. The Pythagorean theorem says this: a squared plus b squared is equal to c squared, where A and B are the legs of the right triangle and C is the hypotenuse. So ultimately, in order to find the hypotenuse of this right triangle, we're going to be solving this equation such that we get C equal to something by itself. And again, A and B are the legs of a right triangle. So let's say this is 5 and this is 6. We can let A be 5 and B be 6. So let's go ahead and plug those in accordingly. This becomes 5 squared plus 6 squared equals C squared. Of course, as I just mentioned, we're going to be solving the Pythagorean theorem for C. 5 squared is the same thing as 5 times 5, which is 25. 6 squared is the same thing as 6 times 6, which is 36. This equals C squared. So as not to make any mistakes here, I'm going to add these off to the side. We have 25 plus 36. 5 plus 6 is 11, so drop down a 1, carry a 1. 2 plus 3 is 5 plus 1 is 6. So this becomes 61 equals C squared. Again, we're solving for just C, not C squared. So to get rid of this square here, we're going to take the square root of both sides. This will cross out here, leaving you with C equals the square root of 61. 61 is a prime number, so we can't simplify this any further. So I'm just going to say C is equal to the square root of 61. And of course, that is one of our answer choices. It's B. All right, so that is that one. And if you wanted to, you can write C equals the square root of 61. All right, so number 14 says, which of the following represents an equation of a line? So in this video, I've already mentioned something that should help you figure this one out. Notably that the slope-intercept equation of a line is y equals mx plus b. One thing I want to point out is this. In order for you to have an equation of a line, you have to have an x and a y. And at the same time, this is the most important thing I'm going to say. Your x and y have to be raised to the first power. Once they're raised to the second, third, or fourth power, you have something other than the equation of a line. So for example, let's take a look at b. We have y equals x squared. We can see that our x is raised to the second power. If you were to graph it, it would look like this. Clearly, this is a parabola, not a line, so we know that's not correct. What about a here? We have y equals x to the third plus 5. Again, in order to have an equation of a line, your x and y variables have to be raised to the first power. If they're raised to something other than the first power, you don't have a line. And as a matter of fact, when you have something raised to the third power, your graph will look like that. Clearly, that is not an equation of a line. And again, we should see that this is raised to the fourth power, so that's not a line. And here we have x and y both raised to the first power. If you wanted to, you could go ahead and take this equation and rearrange it by adding 5x to both sides. This will become y equals 5x plus 2, which mirrors this equation of a line that we're familiar with. All right, so again, an equation of a line has x and y variables raised only to the first power. So that is that one. Number 15 says, what is the length of the diagonal of a rectangle if the rectangle has a length of 4 inches and a width of 3 inches? So we're dealing with a rectangle, so let's quickly sketch one of those. And you should know some properties of rectangles before you take this test, notably that this length is equal to this length and this width is equal to this width. Let's go ahead and fill those values in accordingly. According to this problem, our rectangle has a length of 4 inches, so that's 4 there and 4 there, and a width of 3 inches, so that's 3 there and 3 there. And we want to know the length of the diagonal of this rectangle. In other words, we want to know the length of this from here to here. Well, when you put a diagonal on a rectangle, what you create are two right triangles. And if it's helpful, I can go ahead and pull one of those out for you. We know this is 3, and this is 4. So we've seen something in this video already that's going to help us figure out what the length of this diagonal is, because the diagonal of this rectangle, in essence, is just the length of the hypotenuse in a right triangle. Again, the hypotenuse is always directly across from the right angle. So we can actually use the Pythagorean theorem to figure this one out. Again, the Pythagorean theorem says a squared plus b squared equals c squared, where a and b are the legs of the right triangle, and c is the hypotenuse. So clearly this is c. We can let 4 be a and 3b b. Let's go ahead and plug in our legs. This becomes 4 squared plus 3 squared equals c squared. 4 squared is the same as 4 times 4, which is 16. 3 squared is the same as 3 times 3, which is 9, equals c squared. 16 plus 9 is going to be 25, equals c squared. We want c, not c squared, so we'll take the square root of both sides. This crosses out, leaving us with c. Square root of 25 is 5, so c in this case is 5. So we know the length of our hypotenuse is 5, and clearly this hypotenuse is the same thing as this diagonal, so this is 5 as well. So in other words, the length of the diagonal of this rectangle is going to be 5. All right, so that is that one. Number 16 says, if a square has an area of 25 square inches, then what is its perimeter? So we're dealing with the square here, so let's quickly draw one of those. And you should know some properties of squares, notably that all the sides in a square are equal. That is to say, this side is equal to this side, that side's equal to that side, and that side's equal to that side. What's more, you should know that we typically call the side lengths of squares s. So if this side's s, this side's s, this side's s, and this side's s. The question is this: given the area of a square, how are we going to find its perimeter? Well, it's actually pretty easy. We know that the area of this square is 25 square inches. Well, how do you find the area of a square? The area of a square is side times side. Side times side is the same thing as s squared. Well, thankfully enough, we know what a is. A is 25 according to this problem. So let's go ahead and plug in 25 for a. This becomes 25 equals s squared. To get s by itself, we'll go ahead and take the square root of both sides. Cross this out here, leaving you with s. Square root of 25 is 5. So we can see that we have a square in which all the sides are 5. Now the question is, how do we find the perimeter of a square? Well, to find the perimeter of any quadrilateral, you simply add up all of its sides. So that's s plus s plus s plus s. And we know what s is. S is 5. So this is 5 plus 5 plus 5 plus 5. 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. So the perimeter of a square that has an area of 25 square inches is going to be 20 inches, which is B. All right, you do have to know the formulas to find the area and perimeter of squares and quadrilaterals. Those questions appear frequently on the test. And similarly, you have to realize that if you know the area of a square, you can find its perimeter. And if you know the perimeter of a square, you can easily find its area. All you have to do is do some very basic logic like this, and you'll be able to figure those values out pretty easily. Now, since this is a pretty short video, I'm not covering all the topics that could show up on the ASVAB or PiCAT. That said, I just wanted to throw in this bonus question to make sure I included another question about triangles. So if it's not too much trouble, go ahead and work this one out. As you can see, it says, if a triangle has an area of 24 square inches and a base of 6 inches, then what is its height? Well, how do we find the area of triangles? We use the formula area equals 1/2 base times height. And what were we given in this problem? We were told that the area of this triangle is 24 square inches. It has a base, RB, of 6 inches, and we want to know what its height is. So we're going to be solving for h. So let's just plug those things in and solve for h. Area was 24, so in place of a, we'll put 24. This is 1/2. Base was 6, so this is times 6 times h. And again, we're going to be solving for h like that. What is 1/2 of 6? 1/2 of 6 is 3, so this becomes 3h equals 24. Divide both sides by 3 to get h by itself. This crosses out here, leaving you with h on this side. 24 divided by 3 is 8, so h in this case is 8. And that is answer choice B. All right, so that is it for this video. As I said at the beginning of the video, if you answered 75% or more of these questions correctly, you'll be good to go on either the ASVAB or PiCAT. And if you didn't, you should have noticed that in the description of this video, there were links to videos where I discuss how to approach each and every one of these topics. So in light of that, I want to say this again. Stop wasting your money on expensive tutors and online boot camps. Everything you need to pass these tests is on my channel already. As usual, I hope you found this video helpful. And as always, you're more than welcome to leave feedback in the comment section below. And on that note, I'm going to go ahead and cut you loose.
こんにちは。